Salam Doctor, I'm Xie Hong and today I'm going to present about my assignment 1. So by looking at the first questions, the question requires us to determine the magnitude of the resultant force acting on the brackets and its direction measured counterclockwise from the positive u-axis. So this is the diagram. So we have F2 and F1. And in these questions, we have to find the resultant force of F2 and F1. Before doing that, we need to know that if we want to calculate for like resolving the force. So for example, I will need to find Fx and Fy. And the question only given us the force right here and theta. So if we need to find Fx, it will be equal to F cos theta. If we have to find Fy, which the vertical force, it will become F sine theta. This is the first situation. And for the other situations, it will be like, I will have the Fy right here, Fx, and the theta will be at here. So Fy will be equal to F cos theta. But the Fx will be equal to F sine theta. So this is the simple theory behind of the force resolving in two-dimensional diagram. Okay. In these questions, we have to resolve the F2 and F1 into vertical force and horizontal force direction. And then we have to sum the resultant force for each direction. For example, F1, horizontal F1, we have negative 141.42. And for the F2 horizontal force, we have negative 75. So we sum up this together and we get negative 216.42 newtons. And for vertical axis also, we have to sum up the F1 and F2 vertical direction force, and then we will get negative 11.51. And then if we want to get the resultant force, we have to square both of these two magnitude to get the resultant force. This is because of something like Pythagoras theorem. So if we have a square, we have A and B, this is C. So C will be equal to square root of A square plus B square. But before that, we have a requirement which the A and B have to be perpendicular each other. Okay, so this is the theory behind of it. After that, we have to calculate for the angles of the resultant force. So we know that in a triangle, if the line in front of this theta we call as opposite, and this is the adjacent, and this is the hypotenuse. So in order to find this theta, we have sine, cos, tangent, and both of them having their relative formula, which opposite divided by h, adjacent divided by h, and this is opposite divided by adjacent. So by using this formula, we will get our angles. And after that, because of we need to find from the positive u-axis, so both of this horizontal and vertical force having negative value means it located at the negative quadrant, which the negative x and negative y means there will be an angle right here, and the angle right here will be 3.04. So we have 3.04. If we want to calculate from the positive u-axis, it will be right here until here. So from here to here is 180 degrees. And from this axis to this axis is 3.04. So we sum both of them together. So become to 180 plus 3.04. And it will be equal to 183.04 counterclockwise from the positive U axis. So here comes the question 2. The question 2 requires us to determine the magnitude of P and the coordinate directions angles of F3 required for equilibrium of the particles. Note that F3x in the octane showed. So we'll have one particle right here, and this is the position vectors, and both of them having their force F1, F2, F3, F4, and P. So in these questions, we have to resolve these angles, this force into 3 different directions, which the Z direction, Y directions, and X directions. After that, we have to resolve the P force, the force of P symbols into Y and Z direction. Since the P doesn't have any X direction, so the X coordinate will be 0. And for F2, it is located at the Y directions, and therefore the Y direction will have negative 120 Ks, and the X and the Z will be 0 and 0. For F3, we will have unknown for here because we want to solve the question right here. So after that, we know that if the particles is in equilibriums, the sum of their force will be 0, which means F1 plus F2 plus F3 plus F4 plus P will be equal to 0. And by this formula, we can derive another formula which we can find that the force of the 3x means the third force from the X directions, we have 44.31 Newtons. And the third force from the Y directions, we will have the formula like 430.19 0.19 minus 0.94 P. We derive these formulas from these equations. So it's something like a simultaneous equations. And then the third force from the Z directions will have 122.75 minus 0.34 P. So by then, we need to find we need to find the unknown P. Okay, so how can we find the unknown P? We will have 200 square equal to 44.31 square plus this square plus this square. Why? Because we know that if we sum up the square of this 3 direction magnitude, we will have a 200 square of these values right here. So after that, we just do the equation behind, do the solving behind, and then we found that we have P equal to 253.82, P equal to 639.11 Newton. So how we get this? So inside here, we open up the bracket, right? After we open up the bracket, we will have the equations similar like x squared plus ax plus b. So this is the quadratic equations. After we solve the quadratic equations, we will find P equal to 253.82, T equal to 639.11 Newtons. And after that, we substitute these P values into the third force expressions right here. Means we can find the third force in Y directions, the third force in Z direction. So we found that if we're using P equal to 253.82, we will have this kind of value, which is the positive values. And if we use the P equal to 639.11 Newtons, we will have negative values for the Y directions and Z direction for the third force. So how can we choose what to use? Because we can only use one values in this question, right? So we need to see the values calculated from P. So the value calculated from P right here is positive values, means this F3 will be at positive region right here. So, okay. The P calculated having positive values, but the third force calculated have positive value. This means the third force will be located at the positive regions of the graphs, which the 191.60 and will be at the positive y here and the positive z here. But the truth is the F3 is located at the negative region. Therefore, we can use the second P to get the negative values. And this is fulfilling the requirements of the third force having itself inside the negative region. Okay, therefore, we decided to use the P equal to 639.11 to find the angles. So this alpha angles, beta angles, and y angles is their own, like how to say, their own angle from its own axis. So this alpha is corresponding to x-axis, this beta is corresponding to y-axis, and this gamma is corresponding to the z-axis. Okay, let's come to question 3. So question 3, if the moment produced by the 4 kilonewton force about point A is 10 kilonewton meter clockwise, determine the angles theta where 0 less than equal to theta less than equal to 90 degrees. Okay, before doing these questions, we have to draw the free body diagram. Okay, so let us take a look on this diagram. Supposingly, these diagrams, this is the pipe, but I just enlarge it for a better view. So you can see the dotted line right here means they are in solid body. But this solid body is similar to something like this. So we can have, we can resolve the force into two directions, which this is the Fy, this is the Fx. And we know that moment, how to find a moment. Moment is equal to force times S, but this S have to perpendicular. The force have to be perpendicular to the displacements. Okay. So, okay, right here, we know that the moments, the total moment will having 10 kilo, and we need to find an expressions for that. Okay, the expressions is like this. This 3 multiplied by 4k sine theta is equal to the force resolved to here and having a moment right here. You can say it. Okay. And 0.45 multiplied by 4k cos theta is meaning the force right here, the force is acting perpendicular at these directions, and it's perpendicular to this axis. Okay. So how to know that whether it is a negative or it is a positive? So at first I consider the directions being right here is positive. So if I apply a force right here, okay, and this is a free moving, means we can like going up here, going up down here. So if I applying a force right here, the whole plank will be pulled down, right? So it will have a directions, clockwise directions. If I'm having another force, so the first one, the first one is having these directions, which the 3 meter one. Okay, if I'm having a force on these directions, means I pull this plank. Okay, I pull this plank, and then this plank will moving up here. We're moving up here. So you can see that if we it is going against the setup I have set. So this positive and this negative. Okay. So by doing this, we can find the equations, and then we will having a tan equal to 12 sine theta minus 1.8 cos theta. And then because of we having sine and cos together, and we need to make it into only ones in order to calculate out the theta. So we need to square both of the expressions. Because of we know that sine square plus cos square theta is equal to 1. Therefore, we substitute it inside these equations and make it become like this. Make it become like this. And eventually we will get the expression which consists of only cosine angle. And this cosine angles is something similar to quadratic expressions, because we're having cos square, cos square theta, and cos theta. Let me draw something. So it will be something like this is x square, this is x, and this is x, which is equal to 1. So we can do a quadratic expressions, like solving a quadratic expression, the way of solving a quadratic expressions right here. And after that, we will get the theta, cos theta is equal to 0.4379. Cos theta is equal to negative 0.6824. And after that, we find the angles. And we will have two angles, which the first angle is 64.03 and the second angle is 133.03. And since the questions have already mentioned, the angle will be only more than 0 but less than 90. So the only angle that's fulfilling these requirements is the first angle, which is the 64 degrees. Okay, let's move on. Question 4. The winch cables on a tow truck is subjected to a force of T equal to 6 kilonewtons when the cable is directed at theta equal to 60 degrees. Determine the magnitude of the total brake frictional force F for the real sets of wheels B and the total number of forces at both front wheels A and both rear wheels B for equilibrium. The truck has a total mass of 4 megagram and mass centers at G. The same things, before we solving these questions, we have to draw the free body diagrams. So by looking at this diagram, we know that the center of gravity is having a height of 1.25 meter. So here's a 1.25 meters. And the wheel A, from wheel A to the center point, we will have 2 meters. From the center point to wheel B, we have 2.5 meters. And from wheel B to this area, to this place, we will have 1.5 we have 1.5 meter. Okay, and then we will have a tension right here. If we resolve these tensions into two directions, we will have Fy, the verticals, and the Fx, the horizontal force. So it will become something like 6k cos theta and 6k sin theta. Okay, so considering the moment at point B, which the wheel B, okay, I want to declare something. So this means I'm considering if the direction going clockwise, we will have a positive values. If it's going anti-clockwise, we will have negative values. Yeah, this is the meaning of the symbols. So we can see that 4.5 and A, the normal right here, having, since we're considering point B, so if we apply a normal force right here, the whole things we're going clockwise, right? Like, okay, let me show you. Okay, the force acting right here, the whole thing we're going clockwise, right? Because we're going to fix these points. And okay, for the next one is the 4 megagram. Since the 4 megagram is the center of gravity, it will have a directions of going down. So since it going down, the moment will moving anti-clockwise, right? So it will having a negative values. Okay, another point which here. So we having a vertical force right here, and it is going down, right? And for the moment we consider it will going clockwise again, right? So we were having a positive values. This is negative value. This is the positive values. So don't forget that we still have a horizontal force right here. So if we cut this out, we will have something like the point right here and the plank right here. And then, okay, we're applying force right here. But the force is going outside. So the force is going outside. So just try to imagine that if we pull these things with these directions, it will going in what directions? Obviously, it will going at this direction, right? Clockwise direction. Therefore, it have a positive values inside. So from these expressions, we can get the result, which NA is equal to 17.335. And for information, these formulas is calculating the force moment, the moment force. Okay, so we're coming to the next equation to find the NA. Sorry, NB. Okay, I need to see. So in these directions, clockwise, we assume that it will having a positive values, and take a look at the moment at point A, which the point the wheel A. So at the wheel A, the first force we encounter will be the center of gravity. Since we already consider the moment at point A and the center of gravity having the force going downwards, it will make the whole things going this direction, right? So since we already considered if the stuff going in clockwise, we will have a positive values. So again, positive values right here. So for wheel B, the normal of wheel B is going upwards, right? So if the force going upwards, it will go anti-clockwise, right? So it will be negative, anti-clockwise, negative. Okay, here comes this force, the force 6K cos theta. So since the force is going downwards, and then it will going clockwise, and again, it will be positive. Okay, and again, for this horizontal force, if we pull from here, it will go in what directions? It will go in clockwise directions. So this will cause this force to having a positive sign. And therefore, we can substitute inside these equations, and then we can find the normals of wheel B. Okay. Oh yeah, I have missed one thing, which the horizontal directions. Okay. Let me show you the graph. We know that the horizontal directions is only have this and this. Therefore, if the whole system is in equilibrium, we know that the sum of the horizontal directions and the vertical directions is equal to 0. Therefore, we can make use of this requirement and make our own expressions. For example, this expression right here. We know that the sum of the horizontal directions is equal to 0. Therefore, f plus minus 6k sine theta, sorry, 6k sine theta is equal to 0. Therefore, we can solve the equations, become like this, and then we will get the result. Okay. For information, the NA is equal to the total normal forces at both front wheels A, and B is equal to total normal forces at both rear wheels B, and F equal to magnitude of the brake frictional force. Let us take a look at the questions 5. Okay, here comes the questions 5. Oops. Okay. The questions 5 require us to remove the 2.5 kilonewton force and then determine the greatest force P that can be applied to the truss so that none of the members are subjected to a force exceeding either 4 kilonewtons in tensions or 3 kilonewton in compressions. Okay. So imagine we're having a pin right here, and then we're having a 500 Newton. Let's say, so if we're exerting a force right here, there will be 2 force here, 1 known force and 2 unknown force. And by using a system like this, we can find the answer from these questions. The question telling us that firstly, they will have a 2.5 kilonewtons, and if the 2.5 kilonewtons is released, and how much force will be at the point P, and there is a requirement behind this question, which the 4 kilonewton in tension and 3 kilonewton in compression. Okay, so let's take a look at different point. Okay, in solving of this kind of questions, we need to consider different points. Like for each different point, we have to draw the graph something like this to help us find the correct values of the direction of force. Okay, so consider joint A. Joint A. So take a look at here. Okay, how to zoom? Okay, joint A, we're having 45 degrees. So how we get 45 degrees? Since the vertical length is 1 meter, and this triangle, okay, if we're going half, it will be 1 meter at the horizontal and 1 meter at the vertical, means they having the same size, and then they will have there will be 90 degree right here, and 100 minus 90 will be equal to 90 degree, and this 90 degree again we need to divide by 2, and we will get the 45 degrees. This is just simple max. Okay, after that we know the degrees of the point A. We have to consider the force in different directions, and we know that we have P right here, right? So there will be a P force right here, and then the force AB right here, and then this is the force AF. So force AF is force AF multiplied by sine 45 to resolve in the vertical directions, and then we will have FAF equal to 1 over sine 45p and 1.4142p. And this is this means the truss having a tension right there. So why we want to sum the vertical force equal to 0, summation of horizontal force equal to 0, because we have to set the whole system in equilibrium. To make clear of it, this whole system is appear to be equilibriums. And after the 2.5 kilonewton is being released, how much of P can the system withstand in order for the compressions, for the compression not more than 3 kilonewton, tension not more than 4 kilonewtons. Okay. So if the whole system is in equilibrium, the vertical force and the horizontal force the sum of the vertical force and the horizontal force will be 0. Okay, means we can make use of this syarat to make our own calculations and find the magnitude of each thrust. Okay, so the joint A, we're having this, something like here. So if we consider the x directions, we need to resolve this force into x directions. And then we can have the FAF cos 45 is equal to AB, the force of AB, and 1.4142 is cos 45 is equal to force AB, and force AB is equal to P. Why? Because here, okay, we substitute this FAF 1.4142 into cos 45, and 1.142 multiplied by cos 45 is equal to 1, and then 1 multiplied by P is equal to P. Therefore, our force along AB will be equal to P. Oh my God. Okay. So consider joint F right here. So we can take a look that the joint F having the force right here, the force right here. And therefore, we can again make an equation right here. So considering the vertical direction, excuse me, we need to resolve all these force into vertical directions, and then we take the sum equal to 0. And by then, we can find the force along the FB, along the point F and point B. And it is 1.4142. Okay. Oh, sorry, I missed the P. Okay, the Fx. So for the direction, the x directions means the horizontal directions. We will need to resolve the force into the horizontal direction, means FFB sine 45, FAF sine 45 inside right here. Okay, so then we will have this equation, and after that we substitute the values, and then we get minus P equal to FFE, and therefore we sum this up together, and this force again F to E will be equal to 2P, and this 2P will in tension. Okay, for the joint E, the things is the same. We need to resolve all those angles, but because of the angles is already in horizontals and vertical, therefore we can just make an equations right here. So considering the horizontal axis, horizontal directions, the force going right here is positive. The force going right here, the left side will be negative. So negative FE plus positive FEO will be equal to, FED will be equal to 0. And when we substitute it, it will become 2P, and it will be in tension. And for the Fy also the same, because our sum, our vertical force need to be 0 because of we having an equilibrium state. Therefore, FEB is equal to 0. Okay. Considering the joint B, the things is still the same. We need to resolve all those force into horizontal directions and vertical directions, and doing simple calculation from there, and then we will get the FBDs and FBC. So after that, we need to consider whether the maximum compressions and the maximum tensions is how large. So for the maximum, for the greatest tension, we will have 3P. The greatest compression have 2P. Among compressions, the greatest magnitude is 3P. Among tension, the greatest magnitude is 2P. So after that, we have to just calculate these things, and then we will get the P is equal to 1 kN. After that, we will get the P max is equal to 1 kilonewton. For question 6, draw the shears and moment diagram for the beam A in terms of the parameters shown. B, set P equal to 4 kilonewton and A equal to 1.5 meter, L equal to 3.6 meter. So because of we having different time instance, we need to set our own time instant. Okay, let's take a look right here. Since the length right here is A, length right here is L, and the length right here is L minus 2A, right? And here having A. So therefore, we have to set up equation like this for A, for 0 to A, the vertical force will be 0 and V equal to P, and the sum of moments is equal to 0 and moment is equal to Px. And for A to L minus A, the sum of the vertical force will be equal to 0. Therefore, the V will be 0. Because of here, we can take a look at the diagram right here, and then we can take a look again the equation right here. And after that, the sum of the moment will be equal to 0 because of negative Px plus P multiplied by x minus A plus M equal to 0. Therefore, we get M equal to PA. For L minus A to X to L, we will have the sum of the vertical force equal to 0 and V equal to minus P. And the sum of moment will equal to 0 again, and minus P minus M plus PL minus X equal to 0. And M is equal to P multiplied by L minus X. And after that, we can just substitute the values given into the equation right here. And after that, we will get the graphs. So we need to follow the distance strictly. And because of that, we can only get a more accurate graph. For A to A, 0 to A, L minus 2A, here's L minus 2A, and L minus 2A to A, L minus 2A to A. Okay, so this is all my presentations, and thanks for patient on listening it. Thank you.